tell us a bit about the Magico facility and the manufacturing processes, and also how some of the most important operational changes in the last few years have come about?
Well, as you just saw, we have a 30,000 square foot of manufacturing facility here. We do all the design here in-house. We have 5 engineers on site. We do all final assembly here. Finally QC. We have a machine shop here with 5 CNC that is working around the clock producing parts. This also facilitates the music room that you see here, where we finally test, listen, and exhibit our product. As you notice, in the last couple of years, we have elevated our R&D abilities to a new level, purchasing the Klippel near-field measurement system and 3D laser vibrometer, which allow us to really take design matters into new heights. And I think that's pretty much what's going on here in this location.
Okay, so Magico's always been known for advanced materials in driver design and in computer design. How do these developments come about, and what excites you about these new materials that you're using from maybe outside of the audio industry?
Well, early on, when you realize what it takes to build the ideal drivers, if we concentrate on, let's say, the diaphragm, just for the sake of examples, a pistonic diaphragm that would also be light and infinite stiff, you start looking for materials that can comply with these needs. They're not always found in traditional loudspeaker manufacturers, which for many years and still are dominated by either polypropylene or paper cone or fiberglass and things that do not produce the pistonic motions that we are looking for. So you start looking for options. What is out there that is perhaps used in other manufacturers that would be both extremely stiff, well damped, and light. That's how you come across materials like graphene, nanotubes, which we started early on with, aluminum honeycomb that now we're using for sandwich between 2 light fiber, carbon fiber skins, and so on and so forth. So we're always looking for what can be improved on the processes and materials that we are currently using. And a lot of these answers come from outside our industry.
And have the new materials, especially in the driver design, have they presented a specific challenge in terms of measuring them with the Klippel system?
No, the measurement parts is actually the easier parts. The manufacturing itself is quite challenging. For instance, bending an aluminum honeycomb to a shape of a cone is extremely challenging. It requires tremendous amount of pressure, and we had to develop new tools that would allow us to do that. We're talking about 50,000 pounds of pressure at certain drivers to be able to form the actual cone to the right shape. These are the main challenges in finding these materials and trying to apply them to what we do. Not measurements. The measurement is the easy part once we get there.
Okay. And we did speak about this, if we can just mention it briefly, the correlation between some of the measurements and then the listening impressions within the context of this amazing listening space.
Well, ideally, you always eventually would like to hear your speakers outside of the room interaction that it will have, and any room will have interaction on any speakers. Filtering out the room from the equation is extremely challenging. So you always end up sitting a bit in the dark trying to correlate between what you design, what you measured, and what you're hearing. Our main goals for many years was to try and build a room that will have the least amount of room gain possible. And that is a very daunting and difficult task to do. And we can go into that, but that's a long story of why is it difficult and why have room gains and how to get rid of it. But we finally, in this particular room, gotten to a point when the room gain itself is happening at extremely low frequencies, and the reverb time of the room is extremely linear across just about all octave that are relevant to listening/testing design that are finished. So we are now at a point where we see a direct correlation with design, simulation, emulation, measurement, and actually listening test.
Okay, so you come from an industrial design background, and you have obviously technical expertise in acoustic design as well. Do you find there are conflicts sometimes between a particular concept, industrial design concept, and what you're actually trying to do as far as a loudspeaker and on an acoustic field?
Yeah, absolutely. That's the challenge of form design form. We have we might have some fabulous ideas in terms of shape and designs which don't conform well to the actual needs of what the design should be. For instance, we are always dancing around particular points that cannot be changed, like tweeter heights. It always has to, in our case, we believe strongly in that, a tweeter should be right at listening height, ear level, which kind of puts it in a very specific spot. So that spot, which is around 38, 39, 40 inches, cannot be moved. So a lot of the design elements are dictated by the fact that you have so much space below the driver, below the tweeter, and so much space above it to stick the rest of whatever it is that you're trying to do. And that creates issues of aesthetic, of just simple population, is where to put what and how to actually contain all this real estate, giving the fact that some of it has to be below the tweeter and the rest of it would have to be above it. Okay.
Now, we can go into this briefly because it's a big topic. But so Magico's pioneered the use of aluminium enclosures for the speakers, and now there's a few manufacturers that are doing similar things in terms of the external material. What's Magico doing that's different?
Well, I'm not sure what others are doing. I can tell you what we are doing. Very clearly on, as I exhibit to you, we identified a major problem with just coupling drivers to the bevel that the speaker is made of, which is typically MDF or some sort of wood or plastic. There's only so much torque you can actually apply to the bolts that are holding the drivers. The bolts, because of the constant vibration the drivers is going through, the bolts get loose very quickly. Once the bolts are loose, you no longer have good coupling, and you start losing a lot of energy to that lostness. I'm sure all of you have exhibit the effect of what happened when you bolt the driver tight again into your speakers. With MDF, you can only do it so much. There's only so much torques you can put in before you strip the threads, and you just never really have a constant delivery of energy because of that issue. So once you start going down that road of how to couple properly a driver to a speaker, of course you get into the aluminum option. And from there on, we developed this whole system of how to build an aluminum skeleton that is free of coupling to the actual skin structure of the loudspeaker. So it started with the Mini, where you have an aluminum front and a spine in the back with rods that are going through it and actually squeezing the skin, the middle skin, between those two plates, and create a constant tension that can also be torqued without worrying of stripping anything while doing that. That creates a very substantial amount of tension that is always constant on the speaker. And the ideal coupling setup to a driver, which is really kind of the basic of proper loudspeaker design. And from that on, we developed a more elaborate concepts of aluminum skins, or these days with the M series carbon fiber skins, and aluminum apparatus that actually attaches the moving elements of the speakers in such a way that they are the only ones that are moving.
Okay, so the entry point into Magico is the A series, and the flagship series of the Magico line is the M series. I'm just wondering, what are the common philosophies that carry from the A to the M?
Always aluminum baffle, pistonic loudspeaker cone, pistonic tweeter as much as possible, all using beryllium to different extent of stiffness. But we use beryllium on our entry-level A series, and we use the same diaphragm just with a diamond-coated layer on our M series. Of course, a much more elaborate motor system, but the concept is the same, is striving for pistonic motion and an enclosure that would be extremely stiff, yet extremely damped as well.
Okay. So what can we expect in the future? What can you tell us about future designs of the Magico brand?
Not much really. Everything that we do is here to stay. We haven't broken any new grounds in particular based on the path that we already chose quite early on. We keep improving on them, and of course, if we'll find ways to continue, we will. But at the moment, we are way up there in terms of at least the science available to us and around us in terms of what we can actually do next. We're in pretty good spot at the moment when it comes to technology versus manufacturing capacity and capabilities.
Okay, well, thank you very much, Alon Wolf of Magico.
Thank you for coming.